So next up, we're actually going to stick on the topic of common sense and NLP with Marco Baroni, who's coming to us from Facebook AI Research in Paris. Over to you.
Okay. Yeah. Thanks a lot for inviting me. Let me tell you that the ideas I'm going to tell you about are the result of lots of conversations with some colleagues of mine at FAIR, at Facebook Artificial Intelligence Research, and in particular Tomasz Mikolov, that I absolutely have to mention here. So as I think we have heard already today many times in the last few years, there has been amazing progress in machine learning. Nowadays, we are very good, say, at building machines that can recognize and label objects in natural images. They can even learn to play video games just by looking at the pixels on the screen. And they even can do amazing stuff, such as beating some of the world champions in a game like Go that requires some long-term planning. So when you look at results like this, you start wondering if, is this still just machine learning, or are we moving toward AI? And yet, as has already been mentioned, when we look at all this progress, we must observe that there are some commonalities in all the success stories. That are the models are trained to accomplish a single task, although it may be a very ambitious task, such as playing Go. You need a long training phase, typically in the order of millions of labeled training examples, and you need typically a very direct error signal. It's sort of you need to open the brain of the learner and tell them exactly what went wrong with respect to the output they wanted to predict. And in this sense, we think we are still as far from genuine general artificial intelligence as we were a few decades ago. What do I mean by that? If I try to think about how, say, an AI could be useful to me personally, I think about the fact that I live very far away from my parents and they are aging fast. And so what I would really like to have from an AI is, for example, some kind of very flexible assistant, such that, say, my mom could tell the assistant, hey, machine, today my blood test results should be available. Can you help me to pick them up? And the machine maybe has never done that, so it answers, sure, how can I do that? And then my mom tells the instructions. You have to call this particular clinic, and you can see when they're open, and then just book me a cab to go there. This is where I would like to go, and it's very clear that we are still very far from that. So for example, if I ask to the Google Assistant on my phone if it can pick up my blood test results, it will give me some answers which are kind of very reasonable in a kind of general common sense knowledge sort of way. So things like giving me information about what the doctor might be hiding from me about my blood test results, whether I could discover cancer in my blood test, and even whether I'm pregnant. Which I guess, in a very, it comes kind of a bit back to the example of Emmanuel of asking about, whether it's going to be dark before you get home. I mean, this is all very good general information, but it's not what I would want. And by the way, this is not to speak ill of the Google system, which of course does help you with many amazing things. So, but what do we need to move toward a real intelligent assistant? We think that there are basically at least 3 desiderata that we consider fundamental. First, we need a machine that is very flexible. So for example, a machine that if it has never been exposed to the task of finding out about blood test results, is not going to just have to need millions of examples of that, but for example, it can just ask for instructions, and from just a bunch of instructions can learn how to accomplish that goal. Second, and I'm glad that Emmanuel also mentioned this, although you can think of intelligence without language, it is sort of like hard to think that like a form of artificial intelligence that is useful to us as humans will not be endowed with language. At the very least because we need language to tell the machine what we want, and also because probably language is the best way in which we can teach the machine how to do something new. And last but not least, you may have some form of supervision when you are learning, but it's fair to say that in a large majority of cases, the supervision comes in the form of very light error signals. So for example, if I do the right thing, maybe you just tell me thank you, and you don't really give me more detailed information on how I did the right or the wrong thing. So how do we go about addressing these three desiderata? Our idea, what we are trying to do, is to create some kind of environment, some kind of training and test set to encourage the AI community to work towards satisfying these desiderata. How shall we go about it? Well, the mainstream in the field nowadays is that you should always try to learn in the wild. You should always try to learn from real world, large-scale sort of problems, and so your benchmarks should be of this sort. This, by the way, is the first, one of the first hits that you get on Google images if you type the real world. And the point here is that the real world, you know, it's kind of like a big, scary place. And just like, say, you probably want eventually your daughter to be able to navigate in the real world, but probably you will not just send her when she's 2-year-old out there in a large city hoping that she finds her way around. We think that the same holds for machines. And that if we try to just like immediately start with very complex tasks, we are not going to do much progress. So for example, nowadays, at least in the domain of natural language understanding, is very common to propose these large-scale reading comprehension tasks, as they call them. For example, this is an example of one particular data set called Squad, where both in training and in testing, the machine is exposed to paragraphs such as the one you've seen here. Chloroplast main role is to conduct photosynthesis, blah, 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 blah. Then they use the ATP and the NADPH to make organic molecules from carbon dioxide in a process known as the Calvin code, blah, 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 blah. And then there is a question. What is the process of turning CO2 into organic molecules called? Arguably, this is something so complex, it would require to pretty much solve the common sense problem that Emmanuel was talking about. It requires lots of common sense knowledge. Say CO2 is not mentioned, or encyclopedic knowledge. CO2 is not really mentioned in this paragraph. It requires very complex linguistic sort of parsing that, like, starting from this kind of task, the result is really that if you want to like just get a bit of progress in it, you are going to really look for techniques that don't try to do a genuine understanding, but just go for some kind of shallow method. For example, just with some kind of pattern matching and looking for, say, a string like a process known as, you may actually get the right answer here without having understood. And so instead, what we propose in our environment that is called ComAI, for communication-based AI, is that we should instead start with some tasks that are like very small and controlled, but arguably deal with all the sort of big problems that we want to address. In particular, in the ComAI environment, you have a teacher, which is denoted here with E for environment, that keeps proposing to the machine, which is L for learning, an infinite stream of more or less related tasks. For example, concatenate A and K. Mostly these are simple string manipulation tasks. The learner produces some kind of output, and the environment produces feedback, possibly accompanied by some kind of reward. And as I said, this looks very simple, but actually our three desiderata are here. You need a machine that is flexible because although these tasks are, as I said, like maybe even trivial, concatenate A and K, reverse B, R, G, J, they keep changing. So you are not going to see many instances of the same task. You really have to be adaptive. Language plays a big role because, for example, feedback is given often only in linguistic terms. And reward sometimes will come in the form of explicit numerical reward, but maybe sometimes it could simply be something like a thank you note. So the idea is like, let's start small. Let's start with something that really allows us to focus on the big problems that we have without having to have all the overhead that you have in the real world. And notice that like all this might look like very simple because we have like lots of prior knowledge such that say we know what reverse mean, we know what a space mean in a text and so on and so forth. But if we were going to look at this from the point of view of a machine that doesn't know the meaning of bytes, maybe doesn't even know the meaning of bits, then it starts looking like something that is a lot more complicated. And I can also tell you that like together with some of the best reinforcement learning and deep learning experts out there, we have actually trying to experiment ourselves with these tasks, and we find that actually they are extremely challenging. Actually, even something as basic as remembering a previous task after you see a stream of other tasks is something that turns out to be extremely challenging. So this is the machine exposed to a task that it has seen before, and as you see, if something else happens in the middle, current algorithms, as is well known, tends to forget it. So this is just to illustrate that this task might look simple, but actually they are already extremely challenging, and they allow us, I think, to focus on what we think are really the core research problems, which will be, we think that really the key to the solution of how we humans and other animals are so flexible is in compositionality, in the fact that we don't just solve each separate problem as an entirely separate, distinct sort of goal, but we are able to learn some kind of basic general skills and then combine them in a productive manner. So for example, for something like if we see a task like concatenate A and K, another task reverse K R M, and then we see a task reverse concatenate K and XYK, we are probably all immediately or almost immediately able to solve it. Why? Because we are able to put together the solution of simple tasks. And current machine learning algorithms still don't have this property. As I said, like another research problem is how to learn from communication. So problems such as like how to learn when the feedback I give you is not some kind of numerical score, is not some explicit error signal, but it's simply something like wrong. You should instead have done this and that. Interaction that was already mentioned, like can I, as the machine, ask you clarification questions and learn from that? And finally, as I mentioned already several times, it's important to learn not in a fully supervised setup, not even in the classic reinforcement learning setup where you have quite frequent some kind of reward signal, but you really need eventually to move to some kind of scenario in which you have very rarely direct error messages, you have rarely reward, and you have basically to discover yourself which things are beneficial and which aren't. So this is our program. We have open sourced a platform where people can play with this kind of task using their own learner, which this is sort of like a client-server architecture in which the learner can be in any programming language that you are familiar with. Recently, actually, a company in Prague called Good AI picked up our ideas and used ComAI to start what they call the General AI Challenge, which is currently running with a lot of participants. But I think if you are interested, you're still in time to enroll. And are the minutes left here including questions? Or OK, so maybe we have like, is it possible to see a bit of the video, like 1 minute or so?
Hi. In this video, we'll show you examples of tasks that your agent will need to solve in the General AI Challenge Round 1. Let's start the first task. Here, your agent needs to understand that there is some assignment occurring on the input and some feedback occurring on the same input. Notice that there are some numbers appearing on the input. There's 1, 8, 3, 7, 6, 2. At first it doesn't make sense, but after some time the agent will learn that it's receiving rewards when it's correctly predicting the feedback. So for instance, when a 3 dot appears, the predicted feedback is number 7. And if the agent lands this mapping correctly and outputs it not just for 3 but for 4, 6 and so on, he starts receiving rewards. And eventually the agent accumulates enough rewards to move to next task instance. And once enough task instances are solved successfully in a row, the agent gets to the next task. I would like to remind you that your goal in the General AI Challenge is to build a gradually learning agent. An agent that acquires a skill on one task and then uses this skill to acquire another skill on another task. The tasks that we prepared for you build on top of each other to help you test and develop this gradual learning property. In this another task, you see that the problem is different than before. It's, let's say, more advanced. This time you are asked to insert spaces in a provided sequence of letters. The letters are English words, but that's just for ease of reading for us humans. It's easier to explain the task to a human also if it's just English strings. So this task already expects that the agent is able to receive feedback on the input, that it's able to interpret the feedback on the input. And
OK, thanks. So this is probably like the most boring demo that you ever watched, but that's exactly the point here. So like the idea of the Good AI Challenge is that you don't need to do any kind of fancy video processing or anything if you want to focus on the core questions for artificial intelligence today. Actually, it is small tasks will force you to address them. And it is going to be a very original challenge because like there is not going to be a distinction between a traditional training and test set. You have to encounter, you will have to solve new problems in the phase in which you are evaluated. And we are really curious to see how this will pan out. OK, and with this I conclude. So all this is part of our ComAI initiative at Facebook. We actually have a program for visiting researchers who can come to visit us for a few months if they want to work on these topics. Soon we are also going to have a PhD fellowship call related to the project. And with this, I thank you.
Do you have any questions for Marco?
Hi, I'm Jessica from Cambridge. So could you possibly outline some of the approaches you guys have tried to tackle these problems?
Yeah, so first of all, like we have no idea how to solve it. What we are trying to do within our group right now is working on a few ideas. One idea is that, like, say, if you think of standard neural networks today, they tend to just like learn about problems in a holistic manner, in which like they have like a set of weights, and they can just like adapt these weights in a way in which in any way, and then like these weights keep being adapted as the input changes, which leads, for example, to the forgetting problem. So we are experimenting instead with systems where the weights keep growing. So at the beginning, maybe you have a certain number of weights. For those weights, eventually learning stops, but new weights are going to be added. And in this way, we hope to kind of encourage the system to fix skills in some sort of like long-term memory. So this is one of the ideas that we are following right now. The other idea connected, not really connected, sort of like orthogonal, but combined with this idea that you can kind of have a growing and freezing sort of system where you have like a long-term memory, is the idea that like you can think these are like kind of like sequential tasks, for which like nowadays the standard approach will be to use some kind of recurrent system, but current recurrent systems are kind of tied to basically emit an output at each input step, whereas we think that what you need to solve this task is some kind of like internal reasoning. For example, you may want to go inside your memory, pick the solution to problem 1, then the solution of problem 2, then combine them, and then produce your output. So we are thinking of a system which, this is a term that we borrow from Alex Graves, who is at DeepMind, are able to do some pondering. So where they can have some kind of like recurrent steps in which they actually are just thinking. They don't need to produce an output. These are like ideas. We are like working on them. We are getting some kind of results, but this is all I can tell you at the moment. Yeah.
Got one question.
There was also somebody.
Trian from Quizdom. If you didn't have the resources of Facebook, but wanted to move yourself towards general artificial intelligence, what would you do?
Participate in ComAI instead of doing other things like object recognition. Okay. I mean, I think one of actually the reasons we have behind this project is exactly that. Like, I think there are like lots of good ideas out there nowadays, but a dangerous thing that is happening is that maybe there are, like 5 labs in the world where you can have this kind of really, like high-powered approach. And the idea of ComAI is that, like maybe the solution to AI will come from having like very nice new ideas, and these very nice new ideas, maybe, you can test them on some simple bit manipulation task, which will not require you to have, thousands of GPUs. Maybe they will not even require you to have a single GPU. And then to scale up the system, to send it out in the real world, maybe we will need that kind of power. But like, these are something where we really hope to encourage people, to focus more on algorithms and less on brute machine power.
Cool. With that, let's thank Mirko.